Good evening, all. Welcome to Unacademy. Pawan, good evening. How are you, Pawan? Are you able to hear me? Pawan, am I audible to you? Okay, fine. Yes. Okay, good evening, all. Welcome to Unacademy. This is Banu Prakash, expert in GATE and ESC. I did MTech from NIT Kurukshetra. I have 10 years of teaching experience. My subjects are electrical machines and power electronics. BPC 10 is my referral code. Okay, use this. The code you will get 10% discount on Plus subscription and Iconic subscription. Okay. So what are the benefits of the Plus and Iconic subscription? By taking Plus subscription, so you will get live classes from the top educators of the country, and also you will get structural schedule for 3 months, 6 months, 12 months and 24 months. And one more advantage, that is the unlimited practice questions per subject wise and topic wise. And also we will get test series per subject wise and mock test. And by taking Iconic subscription, it is a so we will provide a personal coach, study planner, expert guidance, ESC mains questions and answers. So your personal coach, so he will guide everything until you get a job. Okay, and one other one is a study planner. So here we will provide the study planner exactly for competitive exams point of view, and also we will provide the study material, expert guidance, ESC mains questions and answer. So this Iconic subscription is the best suitable for the ESC preparations, okay, for 1 year or 2 years here. So BPC 10 is my referral code. Okay, use this code, you will get 10% discount on Plus subscription and Iconic subscription. Okay, and what is the price for the Plus and Iconic subscription? The Plus is available for the 12 months, 18 months and 24 months. For 12 months, P is at 27,225 rupees. Per 18 months, P is at 34,650 rupees. For 24 months, P is at 39,600 rupees. Okay. Similarly, another subscription is a Iconic subscription. So by taking Iconic subscription, okay, here this is the we will get all the all the benefits of subscription. So Iconic subscription is available for 12 months and 24 months. For 12 months, P is at 45,225 rupees. For 24 months, P is at 66,600 rupees. So BPC 10 is my referral code. Okay, use this code, you will get 10% to discount on Plus and Iconic subscription. Okay, any more doubts? Iconic subscription is the best suitable for ESC preparation. Okay, for ESC preparation, I recommend you this Iconic subscription. Okay. Okay, listen. In previous class, we had discussed about effect of non-linearities on operation of the transformers. So we had discussed what is the nature of the shape of the magnetizing current and shape of the flux and shape of the induced EMF in case of ideal transformer. Similarly, we had discussed about shape of magnetizing current, flux and induced EMF in case of the practical transformer. Okay, so that is in order to produce the sinusoidal induced EMF in ideal transformer, the shape of the flux here, the shape of the flux wave. Okay, suppose it is a induced EMF. So in order to produce the sinusoidal induced EMF, the shape of the flux should be the sinusoidal nature. So to get the sinusoidal flux in case of ideal transformer, the shape of the magnetizing current is a sinusoidal to satisfy the property of the linearity. Okay, this is in case of the ideal transformer. So we have discussed this point. The similarly in case of the practical transformer, what will happen? Okay. So in order to produce the sinusoidal induced EMF in case of the practical transformer, the shape of the flux should be the sinusoidal nature. So here to get the sinusoidal flux in case of the practical transformer, the shape of the magnetizing current is non-linear. Okay, here this flux magnetizing current should be the peaky wave. So this part we have discussed. Okay, this type of wave structure you can known as the peaky wave here. So here this peaky wave is rich in the third harmonic currents. Okay, so this is the one of the question. Peaky wave or the magnetizing current in case of the practical transformer is rich in the third harmonic currents. Okay, or negative third harmonic current. That's why the resultant will become the peaky wave. So next one, suppose if the magnetizing current is the sinusoidal nature, so then what will happen? The shape of the flux will become the flat tapped wave to satisfy the property of non-linearity. So if the flux is a flat tapped wave, then the shape of the induced EMF is the peaky wave. Okay, this is so the one of the question in the competitive exams. Okay, yesterday we have discussed all these points. So what is the shape of the magnetizing current, flux and induced EMF in case of ideal transformer? The similarly, what are the shapes of the magnetizing current, flux and induced EMF in case of practical transformers? Okay, all of you clear now? Good evening, Shravan, good evening. Okay, listen. So today we will discuss about another important concept in the practical transformer. So that is the switching transients in transformer. So switching transients means at the time of, so simply the behavior of the transformer at the time of the switching. So now suppose here we have assumed the switch, this one is the supply, the voltage Vs. Okay, supply voltage is the Vs, and in this case switch is closed at some the time t is equal to 0. So now this is the switch is closed at t is equal to 0. So what will happen here? This is the when switch is closed, some magnetizing current the flows in this switch. Okay, here is the magnetizing current I nu. So this magnetizing current flows to the primary winding of the transformer. So flux will be created. Okay, this is the time varying nature of the flux. Magnetizing current is also time varying nature of the flux. So this flux produced in the primary winding also links with the secondary winding of the transformer. So due to which what will happen? EMF induced in the primary winding. So now here EMF induced in the secondary winding of transformer. So this is the EMF induced in the primary winding and EMF induced in the secondary winding of transformers. So this, what is the meaning of switching transients? Means that is a behavior of the transformer or nature of the magnetizing current and nature of the flux and also nature of the induced EMF at the time of the switching. Okay, at the time of the transformer is connected to the power lines. Okay, that is nothing but here. So this is a switching conditions. Okay. So let my here I nu is I nu of t. Okay, this is a I nu of t is the magnetizing current magnetizing current of transformer. So what is the meaning of magnetizing current? The current required from the source to create the flux is called the magnetizing current. So how do we define this one? So it is the current required from source to create flux in transformer is called magnetizing current. So now already we know that it is in the order of the 5 to the 6% of the rated current. So let phi of t is a mutual flux or the flux of the transformers here. And similar another terms here, E1, the Vs is the supply voltage of transformer. Okay, these are the terminology used in this diagram. So now this one is a transformer core. So whenever transformer core, whenever primary winding of the transformer is excited with the AC supply, time varying nature of the current passes to the primary winding. So due to which here the flux produced in the primary winding which also links in the secondary winding of transformer, and according to the Faraday's laws of electromagnetic induction, EMF induced in the primary winding and the secondary winding. So here actually in practical cases there are the two states. One is the transient state. Okay, first one is the transient state, and second one is the steady state here. So transient state means at the time of the switching. Okay, this is the at the time of switching. Okay, got it, fine. The transient state, and this is the steady state means the switch is closed. Okay, here switch is the closed for long time ago. Okay, this is long time ago. So that is the switching is the steady state condition. So whatever we had discussed till now about the transformer, that is the steady state condition. So that means switch is closed for a long time ago. So then what is the behavior of the magnetizing current, flux and induced EMF? But this state is okay, here it appears very small period of the time, after that disappear. So that's why finally only steady state condition is present in the any system. Okay, here only at the time of the switching. So for example, if we write the time diagram, so now this is the 0. Okay, now it is the 0 plus. Okay, 0 plus, and this one is the 0 minus, and it is the plus infinity, and this is the minus infinity here. So now from 0 to some pi time constant. Okay, pi time constant. So now up to here, so this is a transient state, and from phi time constant to the infinity condition. So now this one is the steady state condition. So now here switch is closed at t is equal to 0 up to the phi time constant. So this behavior of the transformer, or this is the behavior of the magnetizing current, flux and induced EMF in a transformers. Okay, and after that from the phi time constant to the infinity, that is a steady state condition. Now our topic is the switching transients, that is a transient state of the transformer. Okay, all of it clear? What is the meaning of switching transients? Okay, Pawan. Yes. So just we know already everything in case of the steady state condition, but I am recalling all these points once again. Listen. Suppose let assume here the let the S is the let Vs is the supply voltage. Supply the voltages here. So Vs is equal to the Vm the sine omega t. Okay, sine omega t. So that is it's only under the steady state condition. Initially So let us discuss what will happen under steady state condition. Then I will tell you what will happen in the transient condition here. So under steady state condition, let Vs is equal to supply voltage and this Vs is equal to Vm sin omega t. Now what will happen? Magnetizing transformer is a pure inductive nature. So that here transformer is the pure inductive nature here. So that what will happen, this magnetizing current lags the flux here, the applied voltage Vs by 90 degrees here. So now that's why we can write, therefore, so this is the magnetizing current I nu is equal to, so Im the sin omega t, omega t sin omega t minus 90 degrees here, sin omega t minus 90 degrees. So now this is nothing but here flux is how do we get flux value here? So flux is equal to phi of t or I of t here. So flux phi of t is equal to the number of turns multiplied by magnetizing current, so divided by reluctance here. So this is the number of the, by simplification, number of turns, the Im, the sine, the omega t minus 90 degrees, divided by reluctance of the core. Now simplify this one. Phi of t is equal to, so this value is a phi maximum, maximum value, the sine omega t, omega t minus the 90 degrees here, minus 90 degrees. So now this is the Vs. Let us assume it is the equation 1 and this one is the equation 2 here. Let us assume, so this is the equation 1 and the equation 2. So then what will happen? See, so how do we draw this value? So initially supply voltage, suppose if I draw these two graphs, so this is the supply voltage waveform. So here supply voltage starts from 0. So this is the supply voltage V, here. So it is a phi, and it is a 2 phi. So it is a one time period. So it is the omega t, this is the t values. The here this is the Vs values here. So at omega t is equal to 0, Vs is equal to 0. So at omega t is equal to pi by 2, this is the phi by 2. So then what will happen? So here is it is a maximum value. So this value we can say that V maximum here. So now at omega t is equal, pi is equal to phi, and this cycle will be repeated like. But what about the phi value? At omega t is equal to 0. So now this is a maximum value. So it is the lags the flux. The here this flux is lags the applied voltage by 90 degrees here. This is the lagging position. Lagging the position C. Here. So this is the flux lags here. So it is nothing but this is the extended this way. So now it is the equal to minus the phi m cos omega t, cos omega t. So therefore this is a V of t is equal to the Vm sin the omega t, and this one is the phi of t is equal to the minus phi m the cos omega t here. So therefore this is the flux under steady state condition. Flux under the steady state condition. So what we conclude? So this is a supply voltage is a Vm sin omega t, but flux under steady state condition. So this is the minus phi m cos omega t, where maximum value is equal to phi m values. Phi m. All of you clear my point? So under steady state condition, what will happens? So this is the behavior of the flux and this one is the behavior of the supply voltage. Why negative sign? So simplify this. Phi here this one is a sin 90 minus this is the 90 minus theta is equal to, so how much? The cos theta. but here this minus sign we can write, okay, simplify, okay, here omega t minus theta, minus is a common, so then phi m cos omega t. Now are you clear, Pawan? Phi of t is equal to, yes, so this is the phi of t in the steady state condition. So now let us discuss what will happen under the transient condition. Okay, okay, listen. So what will happen in what will happen under transient condition? The similar way, the let us assume the let Vs is a the supply voltage. Vs is a supply voltage is here, supply voltage. So now this is equal to, so we can write V of t is equal to the Vm sine omega t here. Okay, sine omega t. So in this diagram, the initially, suppose let us assume switch is closed at, okay, here is a, the switch is a closed at t is equal to the t is equal to 0. So now here is a t is equal to 0 condition, switch is a closed. So when switch is a closed at t is equal to 0, then what will happen here? So this is the positive voltage and negative voltage. According to the Faraday's laws of electromagnetic induction, this is equal to Vs is equal to E1. Okay, this one we can write, so that when switch is closed at t is equal to 0, the when the switch is closed, okay, switch is closed, then what will happen here? So V of t is equal to, okay, the induced EMF EF according to Faraday's laws of electromagnetic induction. So now this induced EMF we can write, so this value is equal to, okay, n d phi by dt here. So this is a V of t is a Vm sine omega t. So now where E is equal to my, here is the n, so d phi of t by the dt here. So actually magnitude point of view En. So E is equal to n d phi by dt. So Vm sine omega t values here. So now simplify this equation. So Vm sine omega t, okay, sine omega t. So now it is a phi of t. Okay, this one is a phi of t here. So now that is a, you can write, you can simplify this equation. So now here E of t is equal to phi of t. So that equal to, so 1 by n, okay, 1 by n differentiation of the phi of t, okay, 1 by n, the Vm sine omega t, the dt values here. Okay, so now take integration on both sides. Okay, d phi of t is equal the differentiation on both sides. So it is the integration from the 0 to the phi. Okay, 0 to the phi. So now 1 by n, the integration from 0 to t. So Vm sine omega t, the dt values here, omega t dt. So now this is the here neglected. So here neglected the residual flux. Actually there is a residual flux in the core. Suppose it is a very small, so neglected here. That's why I have taken 0. So therefore you can go by integration, you can get, so this value is equal to phi of t. Okay, phi of t. So is equal to the Vm by the omega. Okay, this is the omega n. So minus of the cos omega t, the plus, okay, some constant k here. So now this is the pi of t equation. So at omega t is equal to 0. Okay, at phi of t here, the at t is equal to 0. So now this pi of t is equal to also 0 values here. So now at t is equal to 0, pi of t is also equal to 0. So we are neglected that residual flux. So that's why we can write 0 is equal to, so minus Vm by omega n, so cos omega t, okay, plus kn. So now by simplification, so this is the equal to cos 0. So now this value cos 0 equal to 1, so that here minus the Vm by omega n, so plus k. So wherefore k is equal to the Vm by omega n values here. So now let assume this is the equation. Okay, here this value we can write. Okay, this is the equation, the 3, and this one is the equation 4 here. So now substitute the equation 4 in the equation 3. So we get, so phi of t is equal to, okay, phi of t, so that is equal to, so minus Vm, okay, this is the minus the Vm, the omega n cos omega t, the plus Vm, the omega n values here. So by simplification, phi of t is equal to, so Vm by omega n, so here omega n into 1 minus cos omega t. Okay, so what about this value? Let us assume maximum value of the flux. So now phi of t is equal to some maximum value of the flux 1 minus the cos omega t values here. So this is a, okay, here the flux in the transient condition, or flux at the time of the switching conditions. Okay, so this one is the flux, okay, flux in transient condition, transient the period, okay, transient period here. Now what is the flux in the steady state condition? Flux is equal to minus of phi maximum. So this flux is the flux in, okay, here steady state condition, okay, steady state condition, but this one is the flux in the transient period. All of it clear? Are you clear now? Phi of t is equal to phi maximum 1 minus cos omega t. So this is the flux in the transient period. What is the exactly flux in the steady state condition? Phi of t is equal to minus phi maximum cos omega t. Okay. So then what will happen? See. Okay. When flux is equal to phi of t conditions. So then what will happen? So we know here phi of t is equal to, we know that phi of t, so that is equal to phi maximum, okay, 1 minus, okay, 1 minus cos omega t, okay, cos omega t here. So at t is equal to, okay, at t is equal to, so this is the t is equal to 0, okay, t is equal to 0. So then what will happen? So then phi of t is equal to, so the t is equal to 0 means cos 0 is equal to 1. So therefore phi maximum, the 1 minus the cos 0 degrees. Okay, cos 0 degrees. So cos 0 is equal to 1, so that you will get the 0 only here. So now similarly at t is equal to pi by 2. So then what will happen? So when t is equal to pi by 2, so now it is a t is equal to phi of 0. So next one, so this one is a phi of, okay, phi of t, okay, this is the phi of t at t is equal to, so now this is a t equal to phi by 2 condition. So now at this point, okay, here is a phi of t at t, for the t is equal to phi of t here. So therefore you can write phi maximum, the 1 minus the cos pi by 2. The cos pi by 2 is equal to 0. So that's why this value is equal to pi maximum 1. Now similarly at t is equal to 5. So this is the flux at t is equal to 5. So this value is equal to, so what will happen? Phi maximum 1 minus the cos pi. Cos pi is equal to minus 1. So minus and minus 1, it is equal to 2 times of the maximum here. So therefore we can write, so phi of t here, phi of t. So at t is equal to 5. Okay, at t is equal to 5. So this is equal to 2 times of the maximum flux. Now this effect is known as, okay, this effect is known as a, so doubling effect. Okay, this is nothing but, so it is a doubling effect in the doubling effect in transformer, in the transformer here. So doubling effect in the transient period of transformer, in transient state of transformer. Okay, so this is occurs only in the transient at the time of the switching condition. So phi of t is equal to 2 times of the maximum flux. All of it clear now? So next one, at t is equal to, okay, here at the t is equal to, so this is the 3 pi by 2, the 3 pi by 2. So then what will happen? So this value is equal to, the phi of t will become, so it is the phi maximum 1 minus, okay, this is the cos the 3 phi by 2. So now simplify, you will get phi maximum 1. So next one, at t is equal to the 2 phi. So now here also phi of t you will get, so phi maximum 1 minus cos 2 phi. So now it is equal to again 0 here. So this is the complete the behavior of the flux. Okay, this one is a flux under steady state conditions. Transient condition. Okay, are you clear now? The flux condition in the transient period. Okay, similarly flux condition in the steady state period. What is the meaning of doubling effect here? So in the transient period, maximum flux here, pi of t at t is equal to 5 will become 2 times of the maximum flux. So this effect is known as a doubling effect in the transient state of transformer. Okay, so let us draw the waveform for this doubling effect of the transformers. Okay, so I will take this is the flux on y-axis. Okay, so initially this is the, let us assume from year to year, this is the 0. Okay, it is a pi by 2, and this one is the phi, here phi, and this is the 3 pi by 2. Okay, it is a 2 phi, and so here is the next one 2 pi by plus 90 degrees here. So let us take first initially magnetizing current. Okay, this is the magnet, the flux of the phi of t. Okay, phi of t. So next one, this axis is the phi of. So this axis is the x here, variation of the time with respect to the time here. So initially we know that the supply voltage, okay, here supply voltage, the Vs, okay, this is the supply voltage, the Vs values here. Supply is a Vs is equal to, so we know that the here let the Vs is equal to the Vm sin omega t. Supply voltage is a reference. So next one, flux is equal to what will happen, phi of t is equal to, so now this is a phi maximum, the 1 minus cos omega t 1. Okay, cos omega t. So this is the flux in the transient state. Okay, so now this is the phi, here is the phi by 2, and this one is the phi, okay, 3 pi by 2, and so this is the 2 phi, and so on. So now after that, here the again it is the reaches to the maximum value and the reaches to the 0. Okay, it is a one time period. So one time period here. So this is the time period from year to year. It is a one time period. Okay, one time period. So then what will happen? The behavior of the flux in the transient period. So in the one time period here, suppose if we write the one more, so like this we will get it is the time t values here. So this one is the flux here. So next one, at omega t is equal to 0. Okay, this was the maximum value, phi maximum. Oh, sorry, it is the v maximum. Okay, v maximum one. Now what about the flux in the transient period here? So similar, this is a, but it is the minus cos omega t. So now this is a, the year, it is a phi maximum in the transient period. Already we have discussed this part. Okay, so now this part, okay, here is a minus cos omega t. Okay, it is the phi of t is equal to minus cos omega t. So this is the flux in the steady state condition. So now it is a v of t is equal to the Vm sin omega t values here. Now what about the flux in the steady state condition? So this is the flux in the maximum value of the flux. So phi maximum in the steady state condition. But flux in the transient condition, when this value is equal to, when omega t is equal to 0. So this is the flux here. Okay, flux in the steady state condition. So next one, and flux in case of, okay, this is the flux in the steady state condition. Okay, this one. And flux at omega t is equal to 0. It is exactly pi by 2. Okay, it is the maximum value of flux. So next one, at phi is equal to 0. So this is the 2 times of the maximum value of the flux. So next one, at 3 pi by 2. So again you can reach us to the maximum value, the pi maximum. So again it is reaches to the phi values here. So this is a, okay, here flux, the in this case, okay, this is a, okay, okay, this value of, okay, it is equal to 2 times of the maximum flux. Okay, it is nothing but the doubling effect in the transformer. Effect in transformers. Got it? Yes, I will tell you what is the disadvantages of doubling effect. I will tell you, Pawan. So in the next half cycle, okay, it is comes like doubling effect, the 2 times of the maximum value of the flux. No, at 3 pi by 2 flux is, it's not 0. Okay, 0 comes here, it is there. So this is the flux here, the minus cos omega t. The flux under steady state condition is a 0. So this is the flux under what condition? So this one is a, so this is the flux phi of t is equal to phi maximum 1 minus cos omega t. Okay, cos omega t. So this is the flux under steady state condition. Pawan. So this red line I have shown here, flux under steady state. This is the transient state. and block 1 is a flux under transient condition or switching conditions. All of you clear? So that how do we define the doubling effect here? So flux produced in the transformer gets doubled. The doubles are 2 times of the maximum value of the flux under steady state condition. So under the transient condition is known as a doubling effect. Okay. So therefore here doubling effect in the sense doubling effect. So flux produced in transient period of the transformer or switching time of the transformer is equal to 2 times of the flux produced maximum value of the flux produced in the true transformer is equal to the 2 times of the maximum value of the flux. 2 times of maximum value of flux in steady state. Steady state is called the doubling effect. Okay, this is the meaning of that is the definition of the doubling effect. Yes, are you clear now? What is the meaning of doubling effect? Ardhamainda Pawan? So now we have a question. What are the disadvantage of the doubling effect? What are the consequences of the doubling effect here? So let us discuss that point. So what are consequences of doubling effect in transformer? Okay, so what is the first here effect is a, so we know that the magnetization curve of the practical transformer. Yesterday we have discussed this part. So how do we draw this magnetization curve here? So this is the magnetization curve of the practical transformer here. Okay, magnetization curve drawn between the flux phi of t versus the I nu of t, magnetizing current I nu of t values here. So now initially as a magnetizing current increases, okay, this way as magnetizing current increases, the flux is also increases linearly. Okay, flux is also the increases linearly. So now in this case, okay, after the whenever flux core gets saturated, so now it is a non-linear curve. Okay, this is a non-linearly. Okay, it is a flux increases non-linear man. So this is the saturated point. Okay, saturated point. So already mentioned that. So magnetization curve of the practical transformer is a non-linear. So like this, okay, non-linear curve. Actually, it has the saturation effect as well as the hysteresis effect here. Okay, saturation and the hysteresis effect. So now this is nothing but it is a saturation. Okay, saturation of the magnetic core. Saturation of the magnetic core or transformer core. Okay, this is a transformer core here. So now what are the consequences of the doubling effect? Okay, first point. So suppose just imagine, so this is the value of the magnetizing current required. Okay, this is the, if it is operated at maximum value. So now this one we can say that maximum, let us assume, so this is the maximum value of the flux. So now value of the magnetizing current is required. So to create the flux here, okay, this is the I nu one. What is the meaning of I nu one here? So let I nu one is a, okay, I nu one is a, the magnetizing current required, magnetizing current, the required from the source, okay, from source to create, okay, this is the to create flux of, okay, this is the to create the flux of phi m, okay, this is the phi m value here, to create the flux of phi m values here. Suppose this is the where you get the pi maximum, 2 times of the maximum value here. Suppose if we get this is the 2 times of the maximum flux. Suppose if we take, okay, this is the phi m, and here you will get the phi of t, and this is the 2 times of the maximum flux. So in order to get the 2 times of the maximum flux, so then what will happen here? So this transformer core goes into the deep saturation, so which demands I magnetizing current from the source. Okay, so in order to produce the 2 times of the maximum flux at the time of the switching, okay, transformer core goes into the deep saturation. So with the deep saturation, which demands high amount of the magnetizing current from the source. So that current is known as a magnetic inrush current. Okay. So first consequence, what will happen due to the doubling effect? The transformer core goes into the deep saturation. Okay, due to the doubling effect, the transformer core goes into the deep saturation, which demands high amount of the current from the source to create the flux. What will happen? Suppose this is a, the let assume, so it is a 2 times of the, suppose here is a, okay, here is a linearly increases. So now after the infinity amount time, it reaches to the maximum value. So suppose, okay, in order to produce the this amount of the current, so then is a flux here. So this value, okay, in order to produce, okay, increment phi nu of tc. So now this is a another value of the maximum flux. So here is a change in the flux in the saturation region. Rate of change of the flux in the saturation region, in saturation, rate of rise of the flux in saturation is a less, okay, as very less as compared to the rate of rise of the flux, the rate of rise of magnetizing current in the saturation region. So that's why what will happen, in order to produce the 2 times of the maximum value of the flux, transformer core goes into the deep saturation, which demands high amount of the current from the source, so which is the undesirable. So that's why here is a, so the current required to produce the 2 times of the maximum value of flux due to doubling, so this current is known as a the magnetic inrush current. Okay. Now are you clear now? So due to doubling effect, so what we conclude here, so due to doubling effect, doubling effect in transient period, okay, transformer core goes into deep saturation, deep saturation, deep saturation, saturation, which demands high magnetizing current, high current from the source, high current from source, okay, from the source, okay, from source to produce 2 times of the maximum flux. So this current is known as magnetic inrush current. Inrush current. Okay, all of it clear? So due to the doubling effect in the transient period, transformer core goes into the deep saturation, so which demands high magnetizing current from the source. Okay, so this is the high magnetizing current from the source to produce a 2 times of the maximum flux. So this current is known as a magnetic inrush current. Okay, so now we have a one question. So what is the shape of the magnetic inrush current? Okay, this is the shape of the magnetic inrush current. So in this diagram, see here, okay, shape of the magnetic inrush current. So this part, okay, here is a, so at the time of from year to year, okay, year to year, so therefore this is the current required, okay, current is the, this one is the current at this point. Okay, suppose year to year, so this part, so very high value exactly at this time, so we required, okay, very high amount of the magnetizing current. So now this is a positive peak and the positive, both are will be increased. So now this is a the increases and this type of, so this is the shape of the magnetic inrush current. Magnetic inrush current here. Okay, so now we have a question, what is the magnetic shape of the inrush current is a, so like this you can write shape per one cycle only. Okay, shape of magnetic inrush current. This is also one of the question. How do we get this shape of the magnetic inrush current? Per one cycle of the year, one cycle. So we have a current like, suppose this is a magnet, per one cycle you will get the current of, so I peak, okay, this is the I value, and next cycle, so you will get, okay, like this. So now it is the next one, and other cycle you will get, okay, here like, so next one is a another cycle. So after some period, okay, here is a reaches to the steady state values here. So this is a from E up to year, okay, up to the year. So this is the transient period, okay, transient period. So now from year to year is a steady state conditions, okay, steady state the condition values. Okay, so now here is a shape of this one. Okay, this is the magnetic inrush current, and what will happen here? It is magnetic inrush current is not symmetrical about the x-axis in the transient period. So that's why it has a odd harmonics as well as a even harmonics. So now in the figure shown, from figure, so we get, from the figure we get magnetic inrush current is not symmetrical about x-axis, so it has even order harmonics as well as odd order harmonics here. That means, so like 2, 3, 4, the 5, 6, 7 and so on. So this is the order of the harmonics here. Suppose sometimes we have a question, most dominant harmonics in the magnetic inrush current here. So which is the most dominant here? Second order harmonics. Okay, this is the, so this order is a first one. The first here, for example, so here the odd order harmonics, which is the most dominant harmonics here? Third order harmonics. So now what is the shape of the magnetizing current here? So this is this magnetizing current in the transient period is not symmetrical about, okay, here not symmetrical about x-axis. So in transient period, okay, in the transient state, so that's why it has the even order harmonics as well as odd order harmonic. But most dominant harmonics is so here is the most dominant harmonics is a second order harmonics. It is the one of the question in the competitive exam. So which is the most dominant harmonics in the magnetic inrush current? So here is a magnetic inrush current is present in the transient state only, but it is not symmetrical about x-axis. So that's why here most dominant harmonics in the in magnetic inrush current is a second order harmonics. All of it clear now? So this is the magnetizing inrush current in the first cycle and next cycle, and after 5 cycles it will be disappear and comes to the steady state condition. So in the steady state condition it is a peaky wave. Okay, yesterday we have discussed that part. In the steady state condition it is a peaky wave. So it is the only dominant harmonics is the third order harmonics. Most dominant, third order also present, third order, fourth order, fifth order, but most dominant here, that is the most effect is a second order. So when order is a less, that will be the more dominant. When order is a more, that is the less dominant. All of it clear now? Okay, next, this is the consequences 1. Okay, first consequence 1 is so transformer goes into the deep saturation, which demands high magnetizing current from the source. So due to which what will happen? So this is the way it demands high amount of the current from the source. So to produce the 2 times of the maximum flux. So that current is known as a magnetic inrush current. So next one, the any other second consequence due to the doubling effect, the here consequence 2, second consequence. Okay, so we know that, okay, here we know EMF induced, okay, here flux is equal to how much? So this is the, we know phi of t in the transient period is equal to phi maximum, the sine, the here is a cos of the omega t minus 1 year. So this is the flux in the transient period, flux in transient state. Okay, so this is the EMF induced here, EMF per phase, okay, is equal to 4.44. So 2 times of the maximum flux. Okay, suppose the initially I will tell you, suppose this is under the transient condition, and this is in case of the steady state condition, the flux is equal to phi of minus the phi maximum cos omega t. So what is the EMF induced here? E1 is equal to 4.44. So phi maximum F tons. Okay, tons, phi maximum F tons T is equal to N. So now otherwise number of tons T, the here number of tons here N1. Similarly, E2 is equal to 4.44, the phi maximum F, okay, N2 number of the tons. So here also what will happen? Suppose in the transient period, so now phi of t is equal to, okay, here is a flux is the 2 times of the maximum. So that is the maximum value of the maximum value of the flux. Then what will happen? So here is a in transient state, so maximum value of the flux, is equal to 2 times of the maximum value. Okay, true. So this is the, therefore EMF is equal to, what will happen? E1 is equal to the, here is a 4.44, the phi maximum means 2 times of the maximum value. So F N1 number of the tons. Now E2 also is equal to 4.44, the 2 times of the maximum flux F N2 values here. So already we know that insulation plays, suppose we have a transformer, example point, so that is a 400 upon 200 volts transformer here. So this is the HV winding of transformer, and this one is the LV winding of the transformer. So now what about the insulation requirement here? That is the insulation potential difference between LV winding and HV winding. So that is equal to 400 the minus 200, so it is equal to 200 volts. So now how much amount of insulation required? The insulation required, so between the LV winding and HV winding, so now that is equal to 200 volts of the insulation here. So now suppose if we place the insulation between the LV winding and HV winding, or HV winding and this one is the LV winding here. So this is the insulation between the LV winding and HV winding. So this is completely in case of the steady state condition. So insulation, so due to the doubling effect, what will happen? The EMF induced EMF in the transformer winding will become double. Okay, due to which they may chance to get the failure of the insulation. Okay. Allah clear point. Second consequences is a, this is a complete in the steady state condition. So here is a EMF induces in due to the doubling effect, the induced EMF in the windings will become double. Yes, okay, that's why. So there is a some extra insulation is provided to withstand the this amount of the insulation. Extra insulation means what will happen? So designing cost also that increases, like. So what we conclude here? So due to doubling effect, okay, I will write here second consequence. So due to the doubling effect, the EMF induced in the transformer winding, okay, EMF induced in transformer winding will become double, okay. So due to which will become double during transient state. So due to which may chance to get failure of insulation, So how do we prevent this problem? So to prevent this problem, so what we have to do here? During the designing, we have to provide more amount of insulation. So this is to prevent this problem during the designing. How to provide more amount of insulation. Okay, so as insulation is the more, then cost of the designing cost of the transformer will be increased. Yes, that is also third one. Okay, relay mal operation of the relay, that circuit breaker will be tripped due to the high magnetizing current. So that is the third consequences, the three. So that is a mal operation of the differential relay. Okay, it is also, that is a circuit breaker, the trip for high magnetizing current. So differential relay is used for this protection of the transformer. So that is the relay will be operated so for high magnetizing current at the time of the switching. So this is a malfunction or malfunction of the differential relay. All of it clear? So these are the consequences of the doubling effect. So now we have a questions here. So which is the best position to close the switch, at omega t is equal to 0 or omega t is equal to at the instant omega, this the supply voltage is equal to 0, or at the instant supply voltage is the maximum value? Can you tell me this question? So we have some question here. Question 1. If the switch is closed at an instant supply voltage reaches maximum value here. So when supply voltage reaches to the maximum value, so then what is the severity of, okay, this one is there, then what will happen in switching transients? What will happen in the switching transients, or what will happen in the transients, AC transients? Then what will happen? See, so this is the one of the question. Or what is the severity of the transient, whether are less or more here? Suppose we know that what is the supply voltage. Okay, we know the supply voltage here Vs is equal to, so Vs is equal to V maximum sine omega t. Okay, and phi of t is equal to the phi maximum 1 minus cos omega t values here. So initially here is a supply voltage is at the instant of, so this is the t here. So now this is the supply voltage. Okay, supply voltage is here. Now what will happen? So this one is a, so here is the maximum value of the flux. Okay, here is the, it is the maximum value of the flux here. Okay, it is a maximum value of the flux, like so. Now here is a phi of t, and this is the 2 times of the maximum value. Okay, and this one is the 5 times of the phi maximum. Okay, here is a pi by 2 condition. Okay, now this one is the phi. So when the switch is closed, when the switch is closed, at an instant of the supply reaches to the maximum value. So that means at omega t is equal to 0. Suppose at omega t is equal to 0. So then what will happen? See, as omega t is equal to pi by 2. So here supply voltage is equal to maximum value. So at what point you will get the supply voltage maximum value here? The supply voltage the reaches maximum value at what point? Maximum value, that is a pi, here is a the phi by 2, omega t is equal to pi by 2 values here. Omega t is pi by 2. So now at omega t is equal to pi by 2. So then what will happen? So at omega t is equal to pi by 2. So therefore this is a phi of t is equal to, okay, this pi maximum, the 1 minus cos pi by 2. So cos pi by 2 is equal to, so this value is equal to maximum value of the flux. So now it is it is equal to it is equal to, okay, equal to the steady state the flux. Okay, it is equal to the steady state value of the flux here. Okay, suppose switch is closed. Okay, the same question. So another question here. If the switch is a close, so there is a one more question. Question number 2. Question number the 2 here. So if the switch is closed, the zero crossing of the supply voltage, crossing of the supply Vs, okay, zero crossing of sub. So that means at omega t is equal to, so supply voltage is a zero crossing point. So now here is a supply voltage crosses the 0, the at omega t is equal to 5, okay, or at omega t is equal to the 5 value, or at omega t is equal to another the 0, 5, 2 pi and so on. So at this point what will happen? So therefore at omega t is equal to the phi. So now what is the value of phi of t? Phi of t is equal to phi maximum. So 1 minus cos, okay, omega t1. So now substitute here. So phi of t at omega t is equal to phi. So then this value is equal to phi maximum 1 minus cos pi. So now it is equal to 2 times of the maximum flux. So therefore we can write it is a 2 times of the flux, 2 times of flux in the steady state condition. Flux in the steady state condition. So now which one? If the switch is closed at 0 crossing of the supply voltage, the severity of the transients are more. Okay, if the switch is closed at the instant the maximum value of the supply voltage, severity of the transients are less. Okay, severity. So now this one is a the here zero crossing point, or suppose here is a zero crossing point, you can take 0 also. Okay, this at this point. So now this is the 0 and pi by 2 and here. So whenever supply voltage crosses the 0, so if the switch is closed at this point, so that is the severity of the transients are more. The switch is closed at this at the closed at this supply voltage reaches the maximum value. So then the severity of the transient the are less. All of you clear my point? So now sometimes we have a question. So which practically switch is closed in between the maximum value to the minimum value. Okay, practical cases. Okay, here. Okay, practically note. Practically switch is close in between minimum value of supply voltage, value of Vs, and maximum value of the Vs. Okay, this is the practical conditions. Okay, switch is the closed, practically switch is closed in between minimum value of the supply voltage and maximum value of the supply voltage. But switch is closed at the minimum, zero crossing point, the severity of the transient is a very high. Okay, so now switch is closed at the instant maximum value of the supply voltage, severity of the transient is a less. Do you want to repeat? Okay, see. In this question, I am asking, suppose switch is a closed at supply reaches. Okay, whenever supply reaches to the, okay, suppose manas transformers undanukondi. Okay, first come to the first slide. Okay, so it transformers low. Are clear my point? Okay, see, is switch and supply voltage. Okay, is supply, this is the supply voltage waveform. Okay, sinusoidal nature. So now this is the 0 point. Okay, here is a 0 and this the maximum value, and this one is the 0 crossing point. So this is the maximum value and this one is the 0 crossing, and this is the 0 crossing point. Suppose if the switch is closed, whenever the supply reaches to the maximum value, if the switch is closed, okay, at the instant, if the switch is closed at the instant supply voltage is equal to maximum value, so this way the what will happen, the flux in the machine, flux in the transformer, the flux is equal to phi of t is equal to maximum value of the flux. Okay, so that a less amount of magnetizing current is required to produce that phi value of the maximum flux in the machine. Suppose if the switch is closed at the instant supply voltage is equal to at the instant supply voltage is equal to 0 or 0 crossing point, that is a phi or the 2 phi and so on. So at this the time we can close the switch. So then what will happen in the transformer here? The transformer core goes into the deep saturation, which demands high magnetizing current from the source. So that's why practically the switch is closed in between these points. Okay, minimum value and maximum value. We cannot close the switch exactly at maximum value, practical case, but here severity of the transients are less if the switch is closed at the instant of maximum value of supply voltage. The severity of the transients are more, the switch is closed at the instant of the supply voltage crosses the 0 crossing point. Now clear? So this is the discussion about the switching transients in the transformer. If you like this concept, please like this channel and subscribe. Okay, all of you got it, this point? Very important discussion. Very important for competitive exams. We have a questions here. There are the three possibility questions. So first one, the possible questions in the possible questions in the interviews or the any time. First one, what is the doubling effect? Okay, this is the one of the question. What is doubling effect in the transformer? And second one, okay, what is the magnetic inrush current? Magnetic inrush current. Okay, so now another one, the magnetic current. So which harmonics is rich means most dominant, rich in the sense most dominant, the rich in the magnetic inrush current. This is also one more possible question. And another one, so if the switch is closed, okay, here is a, if the switch is closed at a instant of maximum value of the supply voltage, instant of maximum value of supply voltage, okay, severity of the transients. The severity there, the switch is closed there, here less. Okay, next one, the similar question, if the switch is closed at the instant of the zero crossing point, zero crossing of supply voltage. So that is the severity of the transients are more. So at this condition, the flux is equal to, okay, here the maximum value of the flux is equal to, okay, only 5 maximum, but in this condition maximum value is equal to the 2 times of the maximum. So that's why transformer core goes into the deep saturation, which demands high magnetizing current. So at this condition, okay, here there is no saturation effect, so that's why very less amount of magnetizing current required to create the flux, as like under steady state condition. Okay, so magnetizing current is a rich in third order harmonics in the steady state condition. All of it clear point? So this is also very important question. Magnetizing current is a rich in third harmonic currents. Third harmonic current in steady state condition. Okay, steady state condition. So next one, the magnetizing current, okay, is the rich in second order harmonics. Second harmonic current in transient condition. So very important questions. So per 1 mark and interviews, these are the possibility question. Yes, but not 90 degree. In between the practically, so switch is closed between the but here switch is closed at between the between the 0 here. The switch is closed in between the 0 and 90 degrees. Okay, but not 0 or but not 90. Mostly it is a switch is closed very nearer to the 90 degrees because transients are very less. This is the practical. Any more question do you want to ask in this concept? Okay. Are you clear now about all this concept? What is the switching transients? Okay, today I stop the class at this point. So this is the Unacademy GATE Telugu schedule, and always here is the machines class, okay, from 4 to 5:30. Okay, maths class 7 to 8. Okay, this geometry class 8:30 to 9:30, and similarly communication system per per EC 4 to 5:30. So there is a triple one more subject, that is the power system. Okay, from the 6 to 7. Okay, 6 to 7. Okay, the Surendra sir is teaching this subject. Okay, 6 to 7 power system class. Okay, attend this class, you will get more benefits from the Surendra sir. He will teach very well. For triple student, this is one of the advantage. Okay, PDF. Okay, Shravan, I will send the PDF today. Actually, కొంచెం పీడిఎఫ్ ప్రాబ్లం అయ్యి నా సిస్టంలో నేను మీకు సెండ్ చేయలేదు. ఈరోజు కంప్లీట్ 3 days ఉన్నాయి కదా, అవన్నీ మీకు సెండ్ చేస్తాను. లాస్ట్ 3 classes నేను పీడిఎఫ్ మీకు గ్రూప్లో పెట్టలేదు, ఈరోజు పెడతాను కంప్లీట్. ఎనీ మోర్ క్వశ్చన్ డూ వాంట్ టు ఆస్క్? Okay, tomorrow we have a class, power electronics class. Power electronics tomorrow 4 to 6. Okay, this is the, we will discuss about the SCR characteristics, constructional details. Total PDF నీకు అన్అకాడమీ గేట్ తెలుగు టెలిగ్రామ్ ఛానల్లో పీడిఎఫ్లో టోటల్ పీడిఎఫ్ ఉంటుంది, ఒకసారి చూసుకోండి. ఓకే, లాస్ట్ 3 days క్లాసెస్ నేను మీకు సెండ్ చేస్తాను. నీకు కంప్లీట్ ఫస్ట్ క్లాస్ నుంచి అంటే గ్రూప్లో నీకు పీడిఎఫ్ ఎలక్ట్రికల్ మిషన్స్ అని సెట్ చేస్తే నీకు మొత్తం కంప్లీట్ ఉంటుంది. ఓకే ఓకే, అన్అకాడమీ స్పెషల్ క్లాస్ డీటెయిల్స్ I will provide to you. Sure. So this is official Creatrix channel which has 150k plus members. Please join in this channel if you want any updates from the Creatrix stream. It is Unacademy GATE Telugu channel. For any updates or class PDF notes, daily class PDF notes. Okay, you will get all daily class PDF notes from the channel only. So please join in this channel. Okay, these are the different type of channels under the Unacademy. One is a Creatrix GATE, Unacademy GATE Civil, Unacademy GATE Telugu. So this is our channel. Please like and share, subscribe this channel. So Unacademy SSC JE, Unacademy Computer Science, Unacademy GATE Questions, Electrical Junction, Unacademy Engineering Foundation, Engineering Pathshala. Okay, thank you all. Thank you very much. Okay, if you want any question, if you want to ask any question, you can ask. Otherwise, I will end the session.